Have you ever really thought about it? I mean, this invisible power that's flowing through your walls right now, lighting up your screen. It's everywhere. We use it constantly, but we can't see it, touch it, or smell it. So that begs the question.
Yeah, how on earth do you put a number on something that's totally invisible? It sounds kind of impossible, right? Well, it turns out there's a really clever way to do it, and we're going to break down exactly how it works. Okay, so first things first. Before we can measure this invisible flow, we've got to understand what it is we're actually trying to measure. Let's get a handle on this thing called electric current.
The easiest way to picture it is to think of a river. You don't see every single water molecule, but you definitely see the river flowing. Well, electric current is basically the same idea, except instead of water, it's a massive flow of tiny little particles called electrons, all moving together through a wire.
So, just to be clear, we're not trying to count individual electrons. That would be insane. What we're actually measuring is the rate of the flow. You know, how much of this electron water is rushing past a certain point in the wire every single second. The more electrons that pass by, the stronger the current. Simple as that. All right, so if you wanted to measure the flow of a real river, you'd probably use some kind of flow meter. So what's the equivalent for our invisible river of electrons? Well, let me introduce you to the perfect tool for the job.
This is an ammeter. This little device is our hero today, designed specifically to measure that flow of electrons. And its name is a big hint about what it does. It measures something called amperes, which we'll get to in just a sec.
And when engineers are drawing out their plans, their circuit diagrams, they have a really simple way to show it. It's just a circle with a capital A inside. That's the universal symbol that basically says, hey, this is where we're measuring the current.
And that brings us to the units. The official unit for electric current is the amp, which is just short for ampere. It's just like how we measure distance in miles or feet. For electricity, we measure current in amps. A small circuit in your phone might use tiny fractions of an amp, but something like your microwave is pulling several amps to get its job done. So, we've got the concept and we've got the tool. Now for the fun part. How do we actually use this thing? How do you connect an ammeter to a circuit to get a real reading? Let's take a look.
Let's go back to our river analogy. You can't measure how fast a river is flowing by just standing on the bank, right? You have to actually put your measuring device into the water. Well, it's the exact same idea here. You have to literally break open the circuit, and then you stick the ammeter right into that path so the current has to flow through it. This setup is called connecting in series.
Okay, this is where it gets really interesting. Because once we start using our ammeter to take measurements, we uncover a fundamental rule about electricity that honestly surprises a lot of people.
So let me ask you this. When electricity flows through a light bulb and makes it glow, it kind of feels like the bulb must be, using up some of that current. It seems logical that the flow would get weaker after it passes through the bulb, doesn't it? So we've got a couple of ideas here. Idea A, the most common guess, is that the current gets weaker as it goes. Idea B, that it gets stronger, seems pretty unlikely. So what really happens?
The amazing thing is, when you actually take an ammeter and you measure the current before the light bulb and then you measure it again after the light bulb, the answer is neither.
And this is the mind-blowing reveal. The flow rate, the number of electrons passing by per second, is exactly the same everywhere in the circuit. The current that goes into the light bulb is the exact same current that comes out the other side. It doesn't get used up at all. I know, that's a pretty wild concept, and it's a fundamental rule in all of electronics. So let's do a quick run-through of the main points just to make sure everything is crystal clear.
So, let's nail this down. Electric current is the flow of electrons. We measure that flow using an ammeter, and the unit we use is the amp. To do it, you have to connect the ammeter directly into the circuit, which we call connecting in series. And the big surprise, in that series circuit, the current is the same at every single point. It doesn't get used up. But that leaves us with a huge, fascinating new question. If the flow of electrons isn't getting used up, then what is the light bulb taking from the circuit to make all that light and heat? What's actually being delivered? Well, that's a fantastic question for another time.